Might as well. It works, right? It fits theme. All right, let's see. Oh, all right, there's that. Yeah, that's right. Watch what you say. We got it all now. This is new. Zoom has an AI companion. That's kind of scary.
Hmm.
I can only hope.
Hmm.
All right, let's do this. I don't think that's the. Bring it back over to the other way. All right. Well, we'll go ahead and get started up today. It's right about 7:30 our time. Thank you everybody for showing up today to our monthly meeting for BSAS Astronomical Society. I'm Tom Beckerman, current president, and I really appreciate everybody being here in person. We have a contingent online as well, so that's good. I know it's a week later than we typically meet, so thank you again for making time out of your schedule. We're going to go ahead and start off with our guest speaker tonight, Dr. Charles Kuhn from the University of Northern Colorado. He is going to give us a talk about Cepheids, which are kind of like pulsating stars. And so I don't know too much about them. And so I'm actually pretty excited to extend my knowledge. And so, Charles, whenever you're ready, go ahead and take it away.
Hey, hi, thank you for having me. As Tom said, I'm Dr. Charles Kuhn. I'm a professor of astronomy at the University of Northern Colorado. And I primarily study pulsating variable stars. Talk today, we're going to kind of focus just on one of these, specifically Cepheids. And as I do this, I'm going to try not to have flashbacks to teaching on Zoom during the pandemic, but at least I'm guessing you're more interested in what I have to say than students who signed up for Astro 101 just hoping to fill a science credit. So should be a little better. And at least a few less black screens that I'm talking to. So that's a positive. So growing up, most kids quickly notice when they go outside that the stars twinkle. And later on, when we go to school in science classes, we eventually learn that, well, stars don't actually twinkle on their own. They look like they're twinkling, of course, due to movement of Earth's atmosphere. And so we kind of are then led to believe that stars are this constant thing, that these things that shine with the same amount of brightness at all times. I mean, and that idea shows up even in Shakespeare with his famous quote, "I'm as constant as the North Star" from Julius Caesar. Well, turns out that isn't exactly true. Not only do stars actually change in brightness, not due to twinkling, but they fundamentally change in the amount of light they're giving off. But the North Star is, in fact, one of these variable stars. So, as it turns out, there actually are a wide variety of variable stars. In fact, most stars vary in some way, shape, or form. Stars that actually are truly constant, even over short time periods, are very rare. The vast majority of stars out there actually vary in brightness, normally in a periodic or multi periodic manner for this. And these brightness variations are caused by physical pulsations or oscillations in the outer layers of the star. And we can detect these changes in brightness by repeatedly measuring the brightness of a star over and over again and plotting that brightness as a function of time. And I think you should all be able to see my arrow maybe a little bit there.
Yep. Yep.
Okay, awesome for that. Now, this field has existed for a long time because some of these variable stars change in brightness by very large amounts, enough that they can be noticed via the naked eye if you're looking carefully over long periods of time. But it's really exploded over the last 20 or so years thanks to the improvement in detector precision, both for ground based telescopes and space based ones. And we've really benefited from the rise in space based missions meant to look for exoplanets. Missions like Kepler and TESS from NASA, like CRO from the European Space Agency, looked for planets that passed between their star and us, blocking a bit of light from that star. And so these missions would stare at stars in space and repeatedly measure their brightness. Great for finding exoplanets, but even better for the study of variable stars. So this field really has changed dramatically over the last 20 years. However, we don't have to go that recently to talk about Cepheids. So, as I said, there's a wide variety of different types of variable stars. You've probably all seen an HR diagram like this before in some way, shape, or form. The x-axis is temperature, and because astronomers are weird, it's backwards. So hot stuff is on the left, cold stuff is on the right. It's a historical anachronism, and as I tell my students, there are two things that you should know about astronomers. One, we are really uncreative when it comes to naming things, and so normally our names tell you exactly what you're looking at. And the second thing is we are lazy. Once we have named or come up with something, we don't change it unless we absolutely have to, because that would be all sorts of extra work. And hence why the x-axis is backwards and we just make people live with it. So hot stuff on the left here, cold stuff on the right. And the y-axis is luminosity here. So stuff that gives off a lot of light is on the top. Stuff that gives off less light is on the bottom. And for those who've ever heard anything about stellar evolution, you probably know that stars start off on what's known as the main sequence here, this kind of roughly diagonal line. And this is where they're burning hydrogen in their core, using it into helium. They eventually leave the main sequence. They become red giants. After they become red giants, they do other things and eventually end up as white dwarfs or neutron stars or black holes, blah, blah, blah. And there we go. That is stellar evolution in about 40 seconds for that. So what we're going to care about today, though, is not all these different types of variable stars. As you can see, I could fill several hours talking about different types of variable stars. We're going to focus instead on Cepheids, which are located right about here. So these are essentially giant stars that are on their way to becoming red giants or on their way from being red giants to becoming something else. So these are the process of moving towards or away from the red giant branch. And they pulsate, they physically expand and contract with periods that range from several days up to several weeks. About 2 months is probably getting to the very long end of a Cepheids period. Most of them fall in that range of a couple weeks. And they can change in brightness by a very, very large amount. They can actually get up to about 50 times brighter during this pulsation cycle. And they pulsate because of their outer layers becoming opaque to light and actually blocking and trapping light. So Cepheids are at just the right temperature that near the surface in the outer layers of the star, they are the temperature is just right to fully ionize helium. So to strip both electrons off the helium atom. And what that does is that gives you a bunch of extra particles for photons to run into. If you have neutral helium, you have a nucleus and two electrons attached to it, and they all go around together. That's essentially one object that a photon can hit. But when you ionize that helium, when you strip both electrons off, now you have three objects that electrons can hit, and thus that photons can hit, and thus it makes it harder for photons to move freely through this gas without bouncing off of and running into all these different objects, the nucleus plus those two free electrons. And so what happens is that layer where we are ionizing that helium fully becomes opaque to light. It's dense enough, it's got enough particles that it becomes opaque to light. It traps light. And anyone who ever played with an anemometer, the little pinwheel like thing in a light bulb, maybe as a kid, the little fins are painted red, black and white, and you held it up to a light bulb and it spun. Well, that demonstrated that photons can actually have pressure. They can actually push on stuff. And so when you have an opaque layer like this, the photons are actually pushing on the gas in that layer. And that causes a buildup of pressure. That causes that layer, that outer part of the star, to expand. Now, as a gas expands, two things happen. Pretty much anytime a gas expands, obviously the easy one, density goes down because you're spreading the particles out more. But also the temperature will drop. So as that gas layer expands, the temperature drops. We're no longer hot enough to ionize helium. Those electrons come back, bond with the nucleus, and now we go from three objects for photons to run into down to only one. So light can start to actually travel out of that layer now. We lose that pressure support, and that outer layer collapses back down. As it does, it becomes denser, it becomes hotter, that helium reionizes, it becomes opaque again, it builds up pressure, it expands, and we get this expansion and contraction going on. And this expansion and contraction then leads to this change in the amount of light a star gives off, because we're changing both the radius of the star and its temperature. And any time you change one or both of those things, radius and temperature, you also change the luminosity, the amount of light a star gives off. And so as you can see, it gives off more light and then less light, and it repeats this over and over again. Now you're probably noticing a lot of people would go, oh, well, it's going to give off the most light when it's the biggest or the hottest or whatever. And it kind of turns out that it actually gives off the most light kind of somewhere during the expansion phase, because you have this combined effect of getting bigger, which does give off more light normally, but getting cooler, which normally causes you to give off less light. So there's kind of a sweet spot in here, which is why these things don't quite look like they sync up the way you would expect. And that's, as I said, that's that balance between temperature and radius for these stars. Okay, so Cepheids, they're these pulsating things. Great. I mean, that's kind of interesting. It's kind of cool that they pulsate, that they change in brightness. But beyond the cool thing, why do we care? Well, Cepheids give off a lot of light, so we can see them at large distances, and that's useful because we can actually use them to determine distances in space. And it's kind of a strange idea that we can do that, because the way we do it is by comparing how bright the star is, knowing how much light it gives off, and then using math to figure out the distance. And it's strange that we'd use something that changes in brightness, that changes in luminosity for this kind of thing, but it turns out there is actually a relationship between how much light on average a Cepheid gives off and how long it takes to pulsate. And this relationship was developed in the early 20th century by an astronomer named Henrietta Leavitt. She worked for the Harvard Observatory as one of what was known at the time as the Harvard computers. So it was very rare for women actually to be involved in astronomy back then, largely because most universities would not let female students earn advanced degrees, and that kind of closed off the route. But the head of the Harvard Observatory at that time was a man named Edward Pickering, and he realized that even back then, they had far more data already on hand than they had people who could analyze that data. It's a problem that has only got worse in astronomy. And he realized that, well, this analysis isn't hard. Even a woman could do this, and I don't have to pay them as much. Essentially, he could hire uh, women to work at the observatory analyzing data, and pay them the same amount that you would pay unskilled labor to, to go work on the farm or something back in those days. Whereas male astronomers would actually have to get paid as educated, highly skilled labor. So he came up with this idea where he's going to hire a bunch of women to analyze this data that he has around. It'll save him a lot of money. It'll get him a lot of work done. It'll be great. And, they're referred to as the Harvard computers because they're doing calculations, things like that. Plus, if you refer to them as computers, it makes it easier to ignore the pay differential or the fact that Pickering would often not give them credit for their contributions. So Henrietta Leavitt spent her time studying the light curves, the graph of brightness versus time for Cepheid variables. And she specifically did this for Cepheids that are located in the Small Magellanic Cloud. So the Small Magellanic Cloud is a dwarf galaxy that orbits our own Milky Way. It's very easy to see in the southern hemisphere if you ever get the chance to go visit Australia or South America or Africa or where Antarctica. It's really easy to see if you're there at the right time of the year. You go outside at night, you can't miss it. Or its companion, the Large Magellanic Cloud. Once again, as I said, we're not creative with our naming. And so the advantage of studying these Cepheids in one galaxy is that they're all roughly the same distance from the Earth. And so any difference in the brightness of one Cepheid to another must be because they give off different amounts of light because they're pretty much the same distance away. And so Henrietta Leavitt realized that there was a connection between the period and the luminosity, how much light these Cepheids give off, where Cepheids with longer periods give off more light. They would appear brighter. She wrote this up in a paper, and then Edward Pickering, the director of the observatory, promptly took her name off of it, slapped his own name on it. He did acknowledge in a footnote that she did all the work, but of course he got the publication credit and she got nothing for it. Now, the reason there is this relationship between period and luminosity has to do with the structure of the star itself. So if we zoom in on that HR diagram to just the part where Cepheids are, so remember temperature on the x-axis, luminosity on the y, you notice that Cepheids fall in what this is known as the instability strip. And this instability strip is a pretty narrow range of temperature. So for the most part, stars here are the same temperature, but they can have very different luminosities. You can be way down here and not be very luminous at all, and you can be way up here and be extremely luminous. So remember earlier I said luminosity depends on radius and temperature of a star. So if the temperature is about the same, this difference in luminosity must be due to changes in radius between these stars. So smaller or less luminous stars down here would have a smaller radius, and more luminous stars would have a larger radius. And the larger your radius, the longer it's going to take that star to pulsate. This is a concept that we all fundamentally know. If you go outside and you hear bells in the bell tower ringing, you don't have to look to be able to tell me which bell is a big bell and which is a small bell, because we all know big bells have much lower pitches. They take longer to vibrate. And smaller bells have much higher pitches. They vibrate much quicker, take much less time. It's this exact same concept that is at play with these Cepheids here. And in fact, Henrietta Leavitt figured this relationship out in part due to her understanding of frequency and pitch and harmonics from music. And that is even more impressive because Henrietta was deaf. So, truly remarkable woman. Didn't get the credit that she deserved for this discovery. However, this discovery quickly showed how important it was less than a decade later with the work of Edwin Hubble. So, Edwin Hubble, of course, is known for realizing that the universe is expanding. And he did this by measuring distances to other galaxies and the redshifts of these galaxies. And when he did that, he realized one, that all distant galaxies are moving away from us. And two, the farther away they are, the faster they're moving. And he measured these distances to these galaxies by looking at the Cepheids in these galaxies and using Henrietta's period luminosity relationship to determine the distance to these things. So her work is directly responsible for Hubble being able to figure out that the universe is actually expanding. He would actually go on to finally give her credit for this. So she finally got the credit she deserved thanks to Hubble's work and him actually properly crediting her. And he actually argued that she deserved the Nobel Prize for her work. The unfortunate thing is when he made this argument, he did not realize she had died 3 years earlier, and the Nobel Committee has a strict rule about not giving awards to people who have died. So I guess yay for giving her credit. Not so good for not realizing she had died. Minor improvement, I guess. For it. Nowadays, these days, we actually do refer to this Cepheid period luminosity relationship as the Leavitt law, finally giving her the credit she actually deserves for this. And most astronomers who talk about Pickering, her boss, who stole credit, mostly talk about him in regards to how he hired women and stole credit from them. So maybe justice is finally playing out. So Cepheids, they're good for figuring out distances to things, but they have other uses as well. They are also extremely good at letting us see stellar evolution happening in real time. Normally, stellar evolution takes extremely long periods of time, forever in human timescales. Our sun will be a main sequence star for about 10 billion years. Once it leaves the main sequence, it'll spend about 1 billion years as a red giant. And you're kind of quickly seeing that these timescales are not really ones that we can observe in human lifetimes or even a couple human lifetimes. But remember, I said Cepheids are on their way going to the red giant branch or coming away from the red giant branch. And this movement happens reasonably quickly, only taking some tens of millions of years, which in astronomy, pretty darn fast. And as it moves, as a star, let's say, moves towards the red giant branch, so it's coming from hotter and moving to cooler, its density is going to change. And as its density changes, so too will how fast it pulsates. The denser you are, the faster you pulsate. The less dense you are, the slower you pulsate. And we can measure these changes in pulsation period over a span of decades and actually measure very, very small movements, very small changes in a star's interior structure as a result of its evolution. If we see a star going from hotter temperatures to cooler temperatures as it goes through this instability strip, we're going to see its period getting longer. If we see it going the other way from cooler to hotter, then its pulsation period would be getting shorter. And as I said, we can do this over a span of decades. And in fact, we've done this for a lot of variables out there. This here shows a Cepheid in the globular cluster M13. This is a part of our galaxy. You can see the light curve here of that Cepheid. And what we do is we measure what time either the minimum or maximum occurs. Doesn't really matter which one. You measure what time it is, and you measure how much time it takes till the next one occurs, and over again. And you measure how that period changes over time. And that's what's graphed here on on the right. So you see we have actually about 120 years of data on this one Cepheid. Fortunately, because these things give off a lot of light and they change in brightness a lot, it was pretty easy to observe these changes even 100 years ago when you're doing it by eye and trying to determine brightness by comparing it to the other stars you happen to be able to see. And over those last 120 years, we've realized that the period for this star is actually getting longer. Very, very slightly, but it is getting longer. It's getting longer by about 10 days every million years. So, a little bit of a change, very slow, but very detectable. And so we know that this star is evolving, and that, as we said, that we're going to a longer period. So we are getting warmer. Our star is actually, in general, expanding beyond just that pulsation. Its density is getting lower. It's moving away from the red giant branch, moving towards whatever the next phase of life for it will be. So let's bring this back to the whole title by Shakespeare quote about about being as constant as the North Star. Well, it turns out our North Star, Polaris, is a Cepheid. So in no way, shape, or form was Shakespeare correct. I mean, I guess other than star, he got that part right. But Polaris, our North Star, is a Cepheid. It pulsates, it changes in brightness, and we've actually known about this for quite a long time. Probably not back in Shakespeare's time, but we do know it. Okay, it's a Cepheid, great, woohoo. Well, what makes Polaris very interesting is we don't see major changes in its period. What we do instead see is changes in how much brighter and dimmer it gets. That over the last 100 or so years, the amount of variation in Polaris's brightness had been getting lower. That the variation, the pulsations actually seem to be dying out. Okay, well, maybe it's in the process of leaving that instability strip. Maybe it's not going to be a Cepheid much longer. That kind of makes sense. We could get behind that. But then something weird happened. In the last 20 years, that decrease in the variation of Polaris has not only stopped, it has reversed, and Polaris is getting more variable. That the change in brightness from minimum to max is getting bigger. And that is very hard to explain. In fact, it is very much a point of active research, and we don't exactly know what is causing it. One possible solution that has gained a lot of popularity in recent years has to do with the fact that Polaris is not only a Cepheid, it's not constant, it is also not one star. Polaris is actually part of a triple star system. You have two stars that orbit each other very closely, named Polaris AA and Polaris AB, because once again, not creative with our name. And then you have a third star, Polaris B, that orbits much farther away from those other two, with the Cepheid being Polaris AA, the big one. And so it's one possible explanation for this is that the gravitational interactions between these stars in the system, between the Cepheid and the other stars in the system, can work to dampen or kind of reinvigorate the pulsations due to tidal forces tugging on the star, things like that. But it's still a question we don't know. So even though we've known about Cepheids, we've measured their period, their brightness for well over 100 years, we still clearly have a lot to learn about these very interesting stars. Thank you for your time. Thank you for inviting me, and I'm happy to answer any questions people may have.
Thank you very much, Charles. That was really interesting. So whenever I'm talking about the pointing stuff at the North Star, I need to refer to it as North Stars now, right?
Technically correct. Sure. Yes.
Nice. Nice.
Yeah.
All right. Good deal. Do we have any questions for Dr. Charles?
Now, how did Hubble find this? I think he found the Cepheids in Andromeda, and was that one of the first things he did, or was that later?
I don't remember the exact order he looked at different galaxies. It would be reasonable to conclude that Andromeda would have been first, being the
Sure.
closest of these other galaxies he looked at. It would be the easiest one to spot the Cepheids in. But yeah, off the top of my head, I don't know exactly the order of when he observed what for it. Fortunately, it's not hard to find Cepheids in other galaxies, or at least relatively close ones, because they are very luminous and they change in brightness a lot. So you're really just looking for anything that happens to be blinking.
Yeah.
So I imagine when they were first these relationships were found, this was a really hot topic in astronomy, and lots of people were focused on finding more Cepheids and measuring their periods, et cetera, et cetera. What kind of visibility or interest level in Cepheids is still there?
Cepheids are not one of the hottest topics these days. Frankly, that would be exoplanets. It kind of consumes a lot of that oxygen there. But they're it's a niche community, but it's a community that um has benefited a lot from exoplanet searches, and has at the same time given a lot back to the exoplanet search thing through technique stuff like that. It's still relatively small, um, but there is interest, and it's largely more European actually than in the US these days. There is a very strong um, community researching Cepheids and similar variable stars in Europe. There's far fewer here in the US for it.
What's kind of the biggest outstanding question for Cepheids?
Um, so the big outstanding questions, I think, has to do with things like these changes, not in the period. We're pretty sure why that happens, but in this amount of brightness change, this variability level. Because Polaris is, of course, the example I use here, but it is not the only one that does these things. There are other ones that show similar effects, or that show other more random things. In some Cepheids, for example, we see kind of an alternating, that one pulsation cycle won't get as bright, and then the next one will be brighter, and then it's back to a lower one. So it's kind of this alternating thing, and we think that has to do with higher order pulsation frequencies deep in the star, and lots of interplay with that. So it's understanding these more complex effects is kind of the big thing going on. We're starting to see evidence that even though we kind of describe Cepheids as these nice sine wave like things, as I showed examples of, that maybe that in some of them at least, there may be other frequencies of pulsation happening, but are just very small, and you need extremely sensitive observations to detect these, which is only kind of started coming up in the last decade or so.
Interesting. Are there any Cepheids that I guess we can visualize as as an astronomer with eyeballs and scopes, or do we need something more sensitive?
So Polaris is a very small one. That's a less than 1% variation. The easiest one probably is actually the one that got the class named after it, is the star Beta Cephei in the constellation of Cephus there. And that one, if you're patient, if you have good eyes, if you do some good documentation with the stars around it, you can notice that change in brightness. But once again, you're going to need to observe for a couple weeks. Unfortunately, you can't knock this out in one open house night or public observing night. That would be really cool, but it's more of you got to come back every night for the next 2 weeks kind of thing.
Nice, kind of like what we're doing for the Nova, right?
Yes, very much that kind of thing.
So that would be the precision of like an exoplanet observation, but over a period of a few weeks?
No, exoplanets create much smaller changes in the brightness of their star, normally much less than 1% for it. So exoplanets are much smaller variations. than what we see with Cepheids, which is why we've been able to do at least some Cepheids for 120 years, and only very recently have we, 20 or so years have we been able to do exoplanet transits like this. But that's the same reason that these exoplanet missions have helped us find these other stranger behaviors in some of these Cepheids, because we're getting these really fine signals, finding effects that were too small to notice before.
I can just imagine getting this nice new telescope set up and going hunting for exoplanets and just keep finding variable stars, just ticking you off. I wonder how it happens.
Yes, we annoy the exoplanet people. We often get their hopes up a little bit on there, only for nothing. And yeah, and some of the processing that they want to do on the data annoys us. So it's a mutually beneficial and mutually annoying relationship.
Nice, like marriage. All right.
Yes.
Yeah, we got one more.
Does the sun show any characteristics of a Cepheid at all, or has it?
No. So the sun, being a main sequence star, still fusing hydrogen into helium in its core, is not a Cepheid. There is a chance it could become a Cepheid later on when it leaves the main sequence to become a red giant. And that has to do with details of how much mass it loses as it transitions. There's some details there, but our sun does actually pulsate. Our sun actually pulsates in a much more complicated fashion. Our sun essentially has sunquakes, just like we have earthquakes on Earth. Our sun has sunquakes. That has to do with the outer layer of our sun is convective, so there's bubbles of hot gas rising and sinking. And when those bubbles kind of hit the outer layer of the sun, if they hit at the right frequency, they can induce vibrations in the sun. These are extremely small, but we do study them, and that actually has been the way we've learned about the interior of the sun. But that's a whole nother topic.
I actually was leading to a question I was going to have. On the second slide, you showed a GIF with wobbly stars, and I was going to ask how much does the sun actually have much wobble like you're showing?
Yes, so our sun, would have a wobble kind of similar to what we can see here in this GIF. And in fact, our sun is doing multiple of these at the same time. These would be a single pulsation mode, and the sun would have a lot of them going on at once. And so if you were to look at like the light curve of our sun, how bright it is versus time, it would look much more complicated, kind of like this one here on the bottom, right. And down below is a power spectrum. This shows the different frequencies of vibration, and you can see there's lots of different frequencies going on. And our sun would show something much more like that.
Gotcha. Well, very cool. Any further questions?
Do we know which, if any, of stars are in our galaxy would be the next to be a Cepheid?
Not really, and that's mostly due to the fact that stellar evolution, takes a decent amount of time. It's a fairly slow process, so it's hard to really tell, exactly when one would move into this instability strip and start pulsating, or not. So we could come up with a list of candidates, but we not to the level of going, okay, it'll be this one next, and then let's look over here for the next one after that kind of thing.
Cool. Well, thank you very much, Charles. Truly appreciate you coming, giving us a talk and giving us some of your time. If there's any other questions? All right, Charles, well, we'll go ahead and let you go. Thank you so much.
Well, thank you. Yep, thank you for having me, and always happy to come back if if you ever would like.
All right, whenever you find that groundbreaking Nobel find, you just let us know. All right.
I'll do that. Take care.
All right, take care.
Okay,
Thank
bye.
you.
All right. Let's get this going. See if I can share my screen now. Find my Zoom. Oh, it's on the other screen. Everybody online, you should see fish probably. All right, good. There's a head nod. All right, let's see. Get my screen going. All right, well, good deal. Looks like we have a good contingent online. It's a great talk. Learned a lot. There's a lot of cool things. So thank you all for showing up today. So we'll go ahead and get started off with the official business portion of our monthly meeting. We're coming up pretty close. Our next meeting will be after the 4th of July, and I felt it appropriate to show a fantastic image of the fireworks galaxy, seeing as 4th of July is coming up. So if you're traveling, be safe. Don't blow anything up too dangerously. Of course, by that famed photographer NASA. We also have a really another cool image by a famed photographer, Thea Wellington. She posted an image of the lunar V and X just this last month. So thank you, Theo, for posting that. So some cool things going on in the skies all around us. All right.
What's a VX?
So with at one point in time during the lunar cycle, you get the terminator hits just perfect, and the sun will highlight a couple ridges. And I don't know if it'll actually. Oh, look at that! It does let me zoom. I didn't know that. Look at that. All right, so there's if you kind of use your imagination, there's an X. Let's see if I can get my. No, it's not gonna let me use my laser with the zoom in, but you can see the X, and then the V is up top, and so it's essentially a play with the eyes. See, the sun highlights some ridges before, so half of it's still in shadows. So yeah, it's a certain thing you can find. This is the second time this year I've actually been able to see it as well. So yeah, it's put it on your list of things to find. Next time we'll be sure to post about it, so everybody can kind of go out and take a look. All right, so we'll go ahead and get started up today. Hopefully everybody had a chance to check out the newsletter and see the meetings from our board meeting and last month's member meetings. Anybody have any questions in regards to that? Didn't think so. Keith, did you make it on today? Checking. All right, I have a member report for us. Looks like we've got 193 members now, so steadily growing. Theo, I see that you're on. Do you want to throw a treasurer's report at us?
Yeah, we do have a little bit of money in the bank. Our current bank balance is $9,274.85. The only thing we spent money for this month was for the Zoom account, and we had to renew our post office box. And we got a little bit of money. My son up in Morristown sold some solar glasses for us, so he sent me the money, and we put that in. So that's not a lot going on, but that's okay.
Nice.
Something that we're talking about, because we're finally running out of brochures. We had some made right before COVID, and then COVID, so we didn't use any for a long time. And now it's time, and of course it's outdated. So it's time for a new brochure, some edits. And so if anybody has any strong feelings, I guess I'll post it to the group, maybe what the current one looks like if you haven't seen it. And you're welcome to make some comments or requests, and we'll be, I think, working on doing that. It's not super expensive if you get them printed. Vistaprint did the last one, and apparently for $238 you can get 500. You spend $313 and you can get 1,000. So it's not too bad to get a whole pile made, and then everybody can have some for outreach. So that works really well. Let's see if there's anything else. Social media, our Facebook. Donna's doing a wonderful job of posting a lot of stuff, which is good. So we're liked by 2.3K and followed by 2.5K. And our Twitter is up to 335 followers. So they're dedicated folks. So that's that's about what, our PayPal, we have $346 in the PayPal account. So usually when that gets up somewhere around 500, I slide that over to the bank account. So if we keep getting new members, we'll get there.
Yeah. Other things that potentially could impact the treasurer's report in the future is we're looking at new signage for star parties to kind of help people get parking and let people know where we can set up scopes at and things like that, as well as updating some of our equipment that we have. So stay tuned for future updates on that. Thank you.
I have two of those arrow, like just signs that say Star Party and arrow.
Yeah. Yeah, Chuck had sent an email to me with some really good suggestions since he's hosting a lot of these. So I was going to bring it up at our next board meeting to kind of get a few updates on those as well, just to kind of get a little bit more, I guess, user friendly.
Yeah.
Perfect. All right, good deal. Speaking of equipment, we still have equipment available for loan. The list is in our Google Groups. It is almost updated. Got everything in. We're trying to figure out the best way to go forward with our loaner program. For future, we're going to start moving it towards more of a library kind of thing where you get a 2-month checkout period and then a return so we can lay eyes on it, make sure everything's still functioning, and so we can ask any questions. And then if there isn't a demand for it, probably check it back out, and take it on your way. But more information will be coming for that. If you do have a scope still, let us know how it's going. Let us know if there's anything we can help you with. If you're having trouble setting the scope up or having trouble just finding a place to set the scope up, let us know. Some of these scopes can be, I don't want to say daunting, but just whenever you're looking at it for the first time, you don't want to break it. You don't want to twist anything off. If you have any questions, definitely please reach out to us and let us know how it's going for you. We also host star parties once a month for the public, and so we'd love to have you out with the scope to take advantage of the skies and hang out with some fellow astronomers from BSAS, and we can show you some things with the scope as well. So if you have a scope or you're interested in a scope, just reach out. I actually have the solar scope with me now, so if anybody here at the Dyer Observatory is interested in the solar scope, I have it in my truck right now. I also have a scope for you, and so I can bring things here for future references. So, all right. Into club business. Our upcoming meeting. So our next meeting, just wanted to bring this up at the first, and I'll talk about it before at the end. Next month's meeting, Dyer Observatory has a camp that's scheduled for our typical meeting date of the third Wednesday. So again, just like this month, next month will be pushed a week later to July 24th. So make sure you mark that on the calendar, and you'll hear more information from us as next month kind of goes through. Also, just a change in date. The July board meeting was typically the first Wednesday of the month, but that's July 3rd. And there's a lot of travel going on, and so we're going to push that a week later to July 10th. So just kind of letting everybody know. As I mentioned, the equipment loan program, we're working through some changes to that. We'll let you guys know how that process kind of unfolds. I'm still collecting solar eclipse glasses, so if you see me out or if you have glasses you'd like to donate, reach out to me. And then finally, in our last board meeting, we were discussing image usage for posting on Instagram and Facebook and things like that. And so we know a lot of you are really great at photography and post things into Google Groups and things like that. And so we'd like to use those images to show the public what we do with our group. And so you'll start to see language for opting out of sharing and things like that. So if you post something, we're asking that it's open for us to share. If you would not like it to be shared, just comment on that, and we'll respect that. But with any sharing, we'll definitely credit photographer and any pertinent details you want us to include in there. So, like I said, expect some more language to come out. We'll probably post something to the Google groups, as well as send something through our Night Sky Network portal, just to kind of get it out there, so everybody can kind of get an idea of what that's all about. All right. Any questions so far on the club business? Good. All right. So a couple things on our BSAS Nashville site. This is where we run our club through. It's our home, essentially. We find information on our next member meetings, public star parties, all that good stuff. We also are still selling our Hatch Show prints. We sell, it sounds like, one every other month or so. Still pretty good posters. They'll send it to you for 25 or hand it to you for 20. They're really nice. I always like going to our website to take advantage of the clear sky chart down at the bottom. I did this yesterday, and so as it predicted, we got pretty rainy skies today and last night, or today. So not much to look at there. What you will notice on here is that private star parties are not listed. And so private star parties are something that we hold for members only. And so we have a couple of dark sky sites out along the Natchez Trace that we have access to. And we have a private star party once a month, and we'll post those details through the Google group if people are going out. And so it's a time for, just kind of get under the skies with your own scopes and fellow members to enjoy the hobby that we love. So it's one of those perks of becoming a member. Facebook, as we said, Donna is doing a really great job of getting us going on there. So thank you so much. Here you see an event that is actually happening tomorrow at 7:30 at the Jackalope Brewing Company. It's astronomy on tap, and so take for the tap what you will.
Well, it's the location.
It's at Jackalope Brewery.
Okay.
Yeah, and so it should be a pretty interesting talk.
Where is that?
Is anybody? I'm trying to think of where it's at. Is it in Madison? Gotcha. My brain went straight to tailgate, and that's not it.
Yeah, it used to be on 8th Avenue.
Yeah.
Division, but I think it moved up to Madison.
If you're interested, send a message and we'll get it. We'll find it for you. But it sounds like it'd be a pretty cool event. Listening to the Cosmic Orchestra using AI. So everything's AI nowadays. The joke.
They give free beer to all astronomers.
You would hope that would be out of this world.
It's a wonderful.
Yeah.
Fine. Let me turn this thing off. I was attending the BSAS meeting, and it just ended, and I'm trying to figure out how to turn it off.
All right, we'll go ahead and keep on going. One thing to note, as Theo mentioned, down here I highlighted in the 2.2K likes last time and the 2.4K followers. Check this out. We're now at 2.3 and 2.5. So we're growing and growing, right? Like, we keep on saying you're doing a great job. And it just shows, right? So thank you so much for your help. All right. Sorry, I keep on calling it Twitter. On X, you can find us at BSAS Nashville. It's kind of our common thing. Often find cool articles posted from around the world. Here you can see a post by Alan Dyer talking about the arc of the moon being at its most southerly it's been in, 18 years. And so it's pretty wild to see how low on the horizon that moon was. And so cool things that you can see, astronomy related or local related items. So find us on there. Instagram, Steve is working on this as well, and I'm about to start posting once I find time. But you can find information on our upcoming star parties and hopefully more images that we can share from the groups and you members. If you do have images that you'd like us to share, feel free to reach out to us and send us the images, and we'd be happy to share and get you some exposure on our socials. All right. On Google Groups, we have a few things going on. That just popped up. This is our main way that we communicate amongst members, where you can discuss things like who's going out for the star party, who would like to meet up, what kind of scope can I get, or just general help. Here you can see Theo's post on the Lunar X. There it is. Here you can see her post on Lunar X. This is Chuck's review of the meeting out at Montgomery Bell. Here's Theo talking about s'mores and Beeman. And so, we post pictures and share things on there. And here's a picture that Chuck sent us from the event out at Montgomery Bell. See that there's a couple scopes out there. So it turns out it was a pretty good event. So if you do
like 10 scopes.
10 scopes.
I think we had 10 scopes.
That's pretty good. Yeah. So
yeah, thank you everybody for coming.
Yeah. Yeah, thanks Chuck for hosting that too. So if you are not on Google Groups and you would like to be on Google Groups to get the messages, let us know. Email us at info@bsasnashville.com, and we can get you added to the appropriate places and get you set up. We also run our network, our club through the Night Sky Network. I always talk about this monthly because it's such a great resource for us. We run our rosters through here. And so if you aren't a member and you're thinking about becoming a member, you do need to sign up through Night Sky Network. It's a free sign up here, but if you wanted to become a member of BSAS, there's a fee for that you'll pay on PayPal through our website. But Night Sky Network is a really great tool for outreach and getting ideas of things to talk about, especially at star parties. This is one of their, my brain just shut off. This is one of their highlighted articles talking about July's night sky and things that you can find. And so if you're interested in going out to star parties and wanting to find something to talk about, it usually gives you a couple things that you can focus on and point at in the sky. And people go, wow, you're amazing, not knowing that you just looked at an awesome website. A couple things here, M13. I took this 2 nights ago, big and bright. We also have this Nova potential here that people are really excited about. I think I saw something that the ASP is having like a certificate of observation before and observation during. So when it lights up, if you can mark your observation, I think that they may give you a certificate or some sort of recognition for people that are certificate hunters. So may want to look out for more of that. Cool things in the sky. Another thing that they have in their featured articles, they also had this up in last month, so I didn't have to change the slides. So hooray for that one. They also have ways of getting more familiar with the sky. This is their third part in the series of circumpolar constellations. So basically, these constellations that are rotating around Polaris. So they always kind of seem to be up in the sky, just at different locations, depending on the season. And so, we're getting into summer. And so it's a good idea of getting an idea. Sorry, it's a good idea to understand what all's out so we can focus on our observations. And of course, my favorite little guy here is the Cat Eye Nebula. I try and image it with my little electronic telescope, my dwarf. That thing is tiny, so I have to rely on Hubble images for that. There are some cool things coming up in the night sky. The Planet Brigade is still kind of running around. We see, let's see, there in the mornings of July, Jupiter and Mars are kind of hanging out next to each other. So coming up here pretty soon. That shot with the Pleiades and the moon, I think actually would probably be pretty cool. And I'll show an image of what that potentially could look like. But if you're a morning person and like to get out and observe, you can start catching the planets become more front and center. Also on Night Sky Network, they have links to sky maps. And so really good ways of again, yourself getting familiar with the sky and finding ways to point at things if you're hosting at a star party. So they have a lot of really good educational materials on here on how to find things and things of interest specifically. All right. In terms of past events and outreach, a couple things. On May 18th, we had a public star party at Bowie Nature Park. It was pretty good. I know I was out there. We had a good showing. On June 5th, I didn't put it on here. I was actually out at Fall Creek Falls doing some outreach with the Tennessee State Parks. And so got to meet some cool park rangers and get some inside scoop on potential dark sky sites coming to maybe Virgin Falls. So that'd be kind of fun to go out to. On June 8th, we had a private star party scheduled. I'm not sure. Did anybody make it out?
I ended up going to Ron's place.
You went to Ron's place? Yeah. How were the skies?
They were good for like a couple hours, and then it got cloudy.
Yeah.
But until then, I think it was really clear too.
Yeah.
And then the clouds came in.
Yeah, it's usually how it
You
works.
want to post it on that you were going or thinking?
Yeah.
Okay, I answered him on the post. I wanted to go, but I
Yeah.
was in the middle of retiring and so it was like, when you talk about a whirlwind,
Yeah.
and all the things you have to do.
Well, it'd be a great way to celebrate retiring.
I know, I'm planning on going out quite a bit now.
Well, we look forward to seeing you there. On June 15th, we had a public star party out at Bell's Bend. It was a pretty good turnout. Skies pretty cooperative that night. Got to see the Chinese space station, Tiangong, I think is the something like that, go across. So that was pretty cool. It's the second time this summer I've actually seen it come through. I've always known about the ISS, but now there's another one to kind of look up there and follow across the sky. And then, as mentioned, Chuck had people at the public star party out at Montgomery Bell. And so a lot of outreach going on, getting out to the community, sharing our love of the sky, pretty amazing. Upcoming on July the 6th, so a couple days after the 4th, there is a private star party scheduled at Natchez Trace Parkway, mile marker 435.3, so just after the bridge. If you do plan on observing out on the parkway, we do have a permit that you need to have on you so that the authorities, know that we're out there and that we're not ruffians tearing up the place. So they asked that everybody out there has a copy of it. You can have a copy of it on your phone or you can have a paper copy of it. Word of advice, if you have a paper copy of it, put it in something plastic because stuff turns to pulp when the dew hits and all that stuff. So I just keep mine on my phone. They seem to be okay with that. And then the next public star party, is it at Bell's Bend? Actually, I think it's at Shelby, right?
I think it's at Cornelia Fort.
Cornelia Fort, yeah. I don't know why it didn't get changed on here. This should say Cornelia Fort, out off or pretty close to Shelby Park. And so we're gonna start posting directions online so people can again find us better whenever they're coming out to the star parties. Again, where to set up. Try and get times as well so we can get there to set up. I'm always running a little bit late, so I'm always last to set up, it usually seems, so I need to get better about that too. But if you're interested in coming out with a scope or one of our scopes to interact with the public, feel free to let us know you're coming. All right, so July 13th at Cornelia Fort. All right, coming up in the night sky, we have a few things going on. With the moon coming through. June seems kind of boring. We're all just waiting for that nova to pop. July, the moon and the The moon and the planets are kind of doing some dancing. We're about to enter Milky Way season, and so that's kind of, where people focus on during the summer, but there's still a lot of cool things in the sky. As I mentioned, if you wanted to get up early in July, here's a shot from July 15th at 3:30 a.m. So if you're up, I think that this would be a pretty cool shot in kind of a wider angle lens. Here you have the Pleiades, Jupiter, Aldebaran, and then this is Mars with Uranus right next to it. And so I actually haven't imaged Uranus before, and so I actually may go after it because I still haven't seen it. So pretty cool, easy way to find Uranus on that date. So to look forward to. And again, this is Stellarium. Used to be a desktop app. Now they've also expanded into cell phone apps as well as website apps. And so that's what this is a picture off of. So cool things to see if you like to get all those things coming up. And then last slide for today. I didn't want it to run too long. Again, next month's member meeting is the 24th. So it's a week past when we typically go. And we'll be having a talk from Dr. Strawn, who works with the James Webb and does some really good scientific outreach and communication. And so we're excited to have her next month. And so with that,
hey, Tom,
yeah.
Before you go, I have it's Mike Ryan here. I have a comment and a question.
Yeah, have at it.
Comment, excuse me, fellas and ladies. Comment about the, Steve allowing us to use the site over there at the church there in Franklin. That's a good in-city site, I'll tell you, for all the people that are Franklin members. It's close to get to, and for being in city, it was a pretty decent site. So thanks to Steve for setting that up, and hopefully we'll be able to use that again in the future.
Yeah, definitely.
Secondly, a question. Last year, I think it was last year sometime, we talked about having lanyards for the members. So when we're out in the public, we can identify ourselves as who we are. I might have missed the meeting when that was handled, but is there a way to still acquire the lanyards that we have for members so that we can identify ourselves to people?
Yeah, I actually think that the lanyards got printed. I think I saw Chip online, but we do have them printed. And if you wanted to reach out to us, we can make sure and have it here next time you show up.
Well, yeah. So if they're available at the meeting, and I don't make all the meetings, I understand that, but I'd certainly try to make it so I could have one, because I'm out at a decent percentage of the events.
Yeah.
So I'd like to do that.
Yeah.
I think Chip has the name tags and I have the lanyards or something like that, but certainly they can be at the meetings.
Also star parties. If you let us know, we can try and
to
you there.
I'll throw it in the trunk.
Great, I appreciate that. Thank you for your time and for the meeting.
Of course. Any other comments before we shut
Tom?
down? Yeah.
Yes, Chuck. Just wanted to mention that we are going to have another star party at Montgomery Bell July 20th.
July 20th?
Yeah, that's the week after Cornelia Fort Airport. And I'll be doing the same thing. I'm going to go out early and do some solar observing, and then go into the star party after.
That's perfect. What time are you planning on getting out there?
I usually set up right around 5 o'clock.
Okay.
So I get 5 to 7 or so for solar observing. And I saw a lot of sunspots. I counted about 30 sunspots.
So with the grouping out there, is it an organized thing for like Boy Scouts or groups, or is it just put up a scope out at Montgomery Bell?
No, I just put out the scope. The park did have a sign up, and they had posted about the star party. They did not post about the solar stuff, so I only had a few people that were out in the park anyway. But I think I had about 20 guests come by. And then I put up some astronomy posters down in the pavilion so other people could see that.
Yeah.
If you haven't been there, Tom, the field is right next to the campground. So people can literally walk from the campground out to the field.
Oh, cool.
Bell's Bend.
That's at Montgomery Bell.
Montgomery.
Just different kind of bell. Awesome. All right. Any other business to attend to before we shut down? Perfect. All right. Well, thank you so much, everybody, for your time. Tried to keep this one short since last couple have been long. Hope everybody has a fantastic day. Have a great holiday. Be safe, especially if you're traveling. I am heading to West Virginia this weekend for a big old star party out of Green Bank again. So my annual pilgrimage. So I'll be traveling as well. So everybody stay safe. Look
Have
forward
fun with that.
Yeah, definitely. All right. Take care, everybody.
Bye.
Thanks, Tom.
All right. Awesome. Yeah.
Anybody want to sign in who didn't get a chance? Okay.